Boo boo. Come on, watch out.
You're live?
Yeah. You're fine.
I was gonna give you a little kiss on the forehead.
All right. Testing. Testing. Can I hear anything? Wait up. Little microphone offline. Okay. All right. Welcome to the last stream of the week, Friday stream. Today we're doing a little bit of something in between a paper and coding. We're going to be looking at BigCode. So BigCode is an open scientific collaboration working on the responsible training of large language models for coding applications. So they have a website. You can find artifacts. Specifically, we're looking at StarCoder, which is a 15-point larger than the second smallest llama model. And it's trained on 1 trillion tokens, which contains over 80 plus programming languages. So you can actually go and see what it's trained on. Pre-training data sets, StarCoder data, paper. Technical report on StarCoder. I guess they do have a little paper. Nice. So this is all the different languages here. Let me see. Let me make this big. My guess is this is mostly Python. You have some CUDA in here. Number of volume. ADA, weight, percentage. What is the highest percentage? Java, 11% Java, over 20 million Java files. Let's see, where's Python? LMNO, there's no P. See also table 2, I guess. Okay, here we go. It is. Python, only 7% Python. So more Java than Python, which is interesting. I would have thought maybe Python would have been more popular here. Let's see. Do they have Rust? They do have Rust. 1% of Rust. And let's see, the stack. Yeah, this is something I found yesterday. So you can click here, am I in the stack? And you can put your name here. So I can put my little GitHub username in here. And you hit check, and they'll tell you, and they'll show you. Here you go. So some of my code is in this stack. So in a small way, I am contributing to this giant BigCode model. So BigCode has a lot of people here. Kind of curious, like I'm going to click on some of these team members. Right, I'm assuming this will be sorted based on who contributes the most, and I'm kind of curious to see who these people are. So this person seems like a Hugging Face person. Leandro, so somebody who works at Hugging Face. I guess this person probably also works at Hugging Face. Yeah, Lubna Ben Alal over here. Lubna Ben Alal, Hugging Face. So it seems like most of the people that are contributing to this project are Hugging Face people. Chat with StarCoder. I guess they have an open. Start chatting. Write a code snippet. Write the Fibonacci function in Python. The recursive approach. Yeah, so this is usually the approach that you end up getting in these LeetCode competitions. And we should totally compare. So actually, let's compare it to the GPT answer. Right? Let's copy the exact prompt here. So this is unusual. It called it Fibbo. Usually I see these are called fib. So the fact that it called the function something different is weird. Yeah, here you go. ChatGPT called it Fibonacci. Same choice of n. Capital N is a little weird. Generally in Python, the key, like an argument, wouldn't be called with a capital letter like that. That's a little unusual. Here, GPT uses a lowercase n, which is more standard, I feel, in Python in terms of a naming convention. But the code is basically the same here. Oh, actually, it's not. You see, look at this. BigCode actually has a condition here. It checks to make sure n isn't negative. ChatGPT does not have that. It's kind of cool. I wonder what, let's open up a little VS Code here. So actually, before we do that, I was totally going to play with this, so let's get this installed real quick. So we're going to install this StarCoder. So we're going to come here, we're going to go into our dev folder, we're going to git clone this repo, it's going to clone it into that, we're going to cd into StarCoder. We're going to reverse search and look up the conda create environment. We're going to create a new environment, we're going to call it StarCoder, a new Python environment. Yes. Clear. We're going to conda activate StarCoder. Now we're inside the StarCoder repo, a local copy of it, and we've created a conda environment for it. Let's go ahead and pip install the requirements.txt. Actually, before we do that, let's see what it is. So basically, this is a very simple requirements list here. You have Hugging Face Hub, you have Accelerate, Transformer. So these are all Transformers, Hugging Face. These are all Hugging Face. TQDM is basically just a visualization aid. So that seems pretty fine. Let's go ahead and install that. So it's installing all the things. See how it's installing NVIDIA Triton. Triton is kind of like a CUDA equivalent. It's code that basically goes in between Python and then actually what's running on your GPU. So when you see Triton, that's what it is. Come on, install. Let's see what else we can learn about this. StarCoder base further trained on Python. Okay, so not only they have basically a model that's been trained on the full stack, which is 80 plus languages, but then they have one that's specifically trained on Python for a little bit longer. Star PII, Personally Identifiable Information Detector. What does this do? NER model, when you ask it to read, okay, that's kind of cool. So you can put in your repo, and then it'll tell you if you have any, I guess, keys in your code. All right, so we installed it here. Let's open up a VS Code window here and fine tune. Here's the fine tuning code. Let's see what we got here. This is the README. This is actually, there's nothing here. This is a very minimal code base. Create a data set. Load data set. What is this function? Where is that coming from? Data sets. So data sets is Hugging Faces data set module. So this model is very closely tied to Hugging Face, right? There's no model code here. All of it is basically just pulling from Hugging Face. These are basically just a training script, and the training script, if you look at it, it defines this dataset object, and then you have the run training function here. Uses a low rank approximation here, which is a popular method of fine-tuning where you don't fine-tune a huge amount of variables, you just fine-tune a small amount of variables. Here they're creating a config object, and then you have the actual trainer object here. But all these objects are part of Hugging Face. It's kind of interesting. Hugging Face has basically its own boilerplate at this point for training models. But I bet you that underneath all that boilerplate, it's just PyTorch would be my guess. Okay, let's go to the big project, BigCode here. Code generation is as follows. Print tokenizer or. Let's see, let's copy this. Copy, we'll make a new file here. We'll call it test. Oh, no, that's not what we want. Oh no. Let's remove this weird folder that we just created. Let's touch a test.py. Let's vim inside that test.py. Let's paste the examples and let's write quit. So now we run it. No module name transformers. Well, that's fucking weird. We just installed that. Right? And look at that, collecting transformers. See, maybe it's because we used the wrong Python there. Wonder what tokenizer they're using. You can probably tell based on the pip install, bits and bytes. What is this? Fine tuning. Python import transformers. Okay. Auto tokenizer from pre-trained. You need the use auth token. Okay. So you see here, it's complaining because we don't have the token. So what we're going to do is we're going to copy the token from the TubeGPT repo, which is a project we were working on yesterday. So inside this project, we have a .keys folder because we don't have it here. We're going to have to copy paste our. We're going to have to make a new key. So I'm sure you guys know how to create Hugging Face keys, but you just come over here to your profile, somewhere over here, settings, I guess. Access tokens. Make a new token. We're going to call this star coder. Just give it read access. And then we're going to copy that, and we are going to paste it. So we can make a let's make a little key here. Let's do vim Hugging Face token .txt. Put it in there. Save it. Then actually let's open up our TubeGPT here. And we have some boilerplate that we made for copy pasting the Hugging Face key. So let's do that. put that there. Let's open up a VS Code here. And we'll put it inside our test function here. And we're going to need to import OS in here. We can get rid of this OS path.join. We're just going to literally open this Hugging Face.txt, read that key, and then set it. So this is all we need here. And let's make sure that we use the right name. So we called it Hugging Face Token. Let's copy, Control Z, copy, W, put it in there. That's the name of the file. We're good to go. Okay. Save that. And let's run our test again. Invalid username or password. It's not liking it. What's it not liking? OS Environ Hugging Face key. Repository not found. Hugging Face BigCode tokenizer.json. Okay, so this doesn't exist, is what's going on here? Are we the first people to try this? Oh shit. You are not in the authorized list. You have to ask for permission. That doesn't seem very open. What is that? You need to agree to share your contact information to access this model. Damn. So not only is it trained on your code, but you're not allowed to use it even though it's trained on your code. This is quite annoying. All right, now it's going to take a second before we're allowed to use it probably. At least we can play with it here. Prompt. Let's see. So let's make a new Python file here. We're going to save this as blank.py. And what's a little Python snippet that we can feed it? So maybe one thing we can do is, actually, why don't we ask GPT? That's an even better idea. Let's come here. Can you give me a small programming puzzle that I could use to evaluate a couple different code-based LLMs? The answer should be 1 or 2 lines. Let's see. Let's see what GPT gives us. Write a one-liner function that takes a list of integers and returns the product of all the elements in the list. That is a little bit too easy. Let's see. So, save it here. Hit tab. VS Code is working on it. That's what VS Code produces. Let's see what BigCode produces. We're going to do that. And then we're going to hit generate. And it should auto-complete it. So already you're seeing a little bit of difference here. So VS Code, they always have low tokens on the demo. Yeah. So VS Code gives you like a little, sometimes people do this. So sometimes in the docstring of functions, people will give you an example of how to use this function. That's not something I see all the time. So Copilot giving you that is a little bit unusual. Copilot also saying LST is kind of weird, like just call it a list. You see how BigCode actually did call it a list. So this is technically correct. You have a lambda function, which is basically like an inline function in Python. It takes in 2 parameters here, x and y, and then it basically just returns 1 times x times y. This is really weird. the one here is actually worthless. This is a really weird answer. This is a better answer. I think this answer is a lot more readable. And let's see what GPT gives us. Let's do this. How is the GPT-4 billing? They ripping you off yet? Kinda. I mean, I don't think you have to be careful. A lot of people who complain about GPT-4 using up all the tokens, they're using a bunch of tools that they don't realize are sending a huge amount of requests. Like, a lot of people use the PDF summarizer tools, right? And they don't realize that every time they ask a question, a lot of these PDF summarizer tools are literally pasting the entire PDF into a ChatGPT like API request. So they're like, why do I suddenly have $100 in billing? It's because you're using tools that are very naive about the amount of tokens that they use. So as long as you're careful about how many tokens you use, you're probably fine. Just realize that a lot of these like AutoGPT, PDF GPTs, a lot of these like tools that people have built are not very good about using a huge amount of tokens. Yeah, LangChain is really bad too. It eats up tokens a lot. So just be careful because people are sloppy and they write a lot of tokens. Okay, so Chat GPT or GPT-4 kind of gave us the exact solution that Copilot gave us. Copilot actually gave us a docstring, which is a little bit better. Let's see if it gives us the same docstring. Can you write a docstring for that? Okay, so this is a Google style docstring here. Yeah, this is actually the best of all of them, right? So not only do you have the args, but you also have the returns, and then you also have the little example versus here, Copilot just only gave you the example. Interesting that it chose the exact same first example here, right? 1, 2, 3, 4. But then this second example is different. GPT went for 5, 6, 7, and then Copilot went for 0, 1, 2, 3, 4. Let's see if we have access yet. Let's see if the Hugging Face... nope, we still don't have access. Let's close out of that. StarCoder, refresh. Do I have access yet? Tell me. Tell me. Repository not found. I guess we have it now. I can see this. StarCoder. Seems like it should be fine. Why is this not? Why you no work? Unauthorized for URL. That's incorrect. I do have authority. Look at this. I can see it. We probably just need to restart VS Code, would be my guess. Still taking forever. All right, well, I mean, we can keep going here. How to fine tune. Why do they need torch vision? I feel like you shouldn't need torch vision in torch audio. It's kind of a weird dependency to have for a LLM based on coding. Parameter efficient fine tuning. That's what PEFT stands for. Let's install these dependencies. Go ahead, paste that in there. Failed with initial frozen solve. Okay, so when you see that, that means Conda is having a hard time trying to figure out the exact way to install these dependencies. So that's not a good sign. That might mean that we're using a version of Python that it doesn't like or something like that. Also uses Wanby. I worked for Wanby. Put that in there. Put this in here. Can be fine-tuned to achieve multiple downstream tasks. Our interest here is to fine-tune StarCoder in order to make it follow instructions. Instruction fine-tuning has gained a lot of attention as it proposes a simple framework that teaches language models to align their outputs with human needs. Yeah, this is the RLHF stuff where you have this kind of like supervised learning on examples of what should be good inputs and outputs, right? Good instructions and answers. Rather than a base language model. A lot of times the base language model is just trained on next token completion, right? So it's not super useful if you're going to be prompting it. But I think raw language models actually are better than these fine-tuned language models, especially if they're fine-tuned to be politically correct, if you want to say it that way, you know. You lose out. Stack Exchange is a well-known network of QA websites on topics. Okay, wants to install a bunch of crap, sure. If you train a model with PEFT, you'll need to merge the adapter layers. Yeah, so when you fine-tune these with the parameter efficient fine-tuning, you're not actually pushing gradients into the full model. I think really the only thing you're doing is you're basically adding a couple extra layers that are kind of within the model and then pushing gradients into those, right? It's actually similar to ControlNet and kind of this LoRa idea. It's a very popular way of doing fine-tuning just because it's a lot more parameter efficient. Okay, let's install these. What is bits and bytes? 8-bit CUDA functions for PyTorch. Tim Depner, this guy's fucking legendary. If you guys haven't heard about this guy does all the like hardcore repos on quantization and optimization. This guy wrote all that stuff. Yeah, so this basically allows you to run the model in such a way that the parameters are stored in 8-bit data types, but actually the cool kids now are using 4-bit data types. So that's where it's gotten to. If you're using floating point 32s, you're in the past. Hugging Face CLI login. Maybe that's what we need. Let's put that in there. No module named Chardet. How do we not install that? The fuck is Chardet? Pip install Chardet. go. Now we have Chardet. Token. Where is it? Where are we? Where is our token? I think we had it open, but we closed it. Let's open up that tab again. Here we go. Copy. Paste. Enter. Use token as a get credential. Sure. Login successful. Clear it. Can we finally run this? Can we finally run our little test? Cannot import name auto model for causal LM from transformers. Yeah, so this is what we were running into yesterday with the segment anything model that's available on Hugging Face, is that for some reason transformers module does not have all these models. So like all these examples where they basically just from transformers import a thing, right? Like the transformers module does not have this model. So I don't know why. I don't know if I'm just not understanding something or if the people at Hugging Face just don't understand how it works or like what exactly is going on, but like it's not in there. This is the dictionary for the Transformers module. You see, and just there's none of it in there. There's BERT. Here you go. Here's BERT for token classification, BERT for multiple choice, BERT for masked LM, BERT. You have OpenAI GPT double heads model. You have plenty of things in here. It's just that they don't have this auto model for causal LM and auto tokenizer. Let's see if GPT knows the answer to this. Why do Hugging Face examples always pretend that you can import a class from the Transformers module as such? I keep finding that when I try to run these examples, the auto causal LM is not in the module formers. Is there some expectation of different versions of transformers of the transformer module? Right? Like it just seems weird that if I do pip install transformers and then I do from transformers import the thing and it's like that doesn't exist, then what does it mean? Examples you're encountering are using a different version of the Hugging Face transformers library than the one you have installed. Make sure you have the correct version of the library. Like, sure. Let's install the latest version. How do I install the latest version of this? Let's see. If I do import transformers, you can get it. What is your transformers version? Mine is 2.1.1. So if I go into PyPy and I look at transformers, oh shit, look at that. I'm just using a really old version. Let's maybe that's the whole fucking problem. We figured it out, guys. 4.20. pip install transformers, and we're going to specify this exact version here, the latest one that they have, 4.28.1. Okay, so you see we uninstalled transformers 2.11 and we installed 4.28. All right, so now let's try this. We did it. All right, so that was the issue. The issue was that whenever you use Conda to manage your Python environments and pip as well, it wants to be clever, and it's not going to reinstall a dependency if it already has it installed. So if you install transformers like I did perhaps months ago, and then you try to install it again, it's not actually going to it's not going to reinstall it and use the new version of transformers. It's just going to say, oh, I already have transformers. I guess I'll just use the old one. So in order to fix that, we had to basically hard code the version. We had to say, no, I want you to install transformers, but this specific version, so that it forces pip to go and find this version and install it. So it's downloading model weights here. So you can see 001 of 007, and just the first version of it is about 9 gigs. So that's a little intense. If we actually go to BigCode, usually in the files, let's see, minimize some of this. Do they have BigCode editor, BigCode playground? Let's see. Here we'll be able to see the relative size of things usually. In the files, nope, they don't have the files there. BigCode, do they have the star coder? Hugging Face Chat star coder base, star coder encoder. Nope, that's not there. What about star coder? Star coder files. Here we go. So this is pretty fucking huge. This is 7 files at 9 gigabytes per file. Damn, this model is like fucking 60 gigs. It's quite huge. What do people have to say about this? Not able to run Hello World example. GPU requirement. I was able to load it in under 24 gigabytes. Okay, so people are loading it at the 8-bit in order to get it to fit. Let's give this a little star, dude. Let's give this a little like. Ooh, this is just a GPT-2 model. Interesting. I would have thought that they trained this. I thought this would have been a llama model, right? But no, it's a GPT-2 model trained from scratch, which is unique. It was trained at float 16 precision on 512 A100s. Watch a World of AI video last night. What is World of AI? World of AI. Is this like a guy? Oh, look at this, dude. 6K subscribers. This guy's got good thumbnails. I like this. Star Coder. Yeah, these are like legit videos, though. You know what I mean? Like my videos are like 3 hours uncut, just raw. This is a 16-minute video that's like perfectly cut. Kind of scrolls through the paper. Trains the model. Let's see, what is this guy doing? About. World of AI. Do we know more about this? Who is this? Is this a person? Is this a team? Damn, look at all these videos. This person's balling 3 months ago. This guy's beating me. Let's hit him with the subscribe. Let's like this video too. There we go. Like. Support the community. All right, this is still downloading. This is going to be an issue because I feel like this is going to take like an hour to download all of this. Let's try to do something more tricky. What is a really hard... do you guys want to try to feed it a really hard LeetCode? LeetCode. I have a LeetCode account. It's pretty ancient at this point, but let's see. Daily check-in. 12 notifications. I haven't logged into this in like literally years. Problems. Let's do no thanks. Let's do difficulty. Hard. No thanks. Let's do only Python. What do you want? Sudoku solver, longest merge case sorted list, median of 2 sorted arrays. It needs to be something that like we can even understand, you know. Distinct subsequences, maximum gap dungeon game. Let's see, median of 2 sorted arrays. C++, dude, fuck that. Python 3 is the answer. Let's see. Let's copy this. Put it into GPT. New chat. Put that in there. We don't actually want plugins. We want GPT-4. Let's see. And let's go to BigCode. New chat. Star coder. Here you go. Give me that. And the reason I kind of chose this is that find median of sorted arrays kind of inherently tells you what you want it to do, right? Like some of these LeetCode problems are like needlessly complicated. Like they have all this setup. They have like basically this like long setup, but I just want the problem. All right. So what do we get here? All right. So compares the lists, the length of these lists. Can I make this bigger? Let me do this. Then it gets assigns that to the length list, assigns a low and a high. Then it basically goes from the low up. You see, low up and then high down. So it's kind of doing this like searching from both directions and then eventually meet in the middle solution. All right, so let's copy that. And let's paste it into LeetCode and see what LeetCode tells us. Let's put this here. And let's hit run. Accepted. Okay, submit. Let's see what we get. Damn, pretty fucking good, GPT-4. So it's at the very top of the speed. Or no. This is actually quite bad. This is really bad. Okay, so runtime lower is better. So here, this is the fastest solutions right here. And this is the memory. So whenever you're doing LeetCode, right, you're evaluated on two things usually. Basically, how much memory does your solution take? And then how fast does it run? And a lot of times those are kind of a trade-off, right? Like, for example, recursive approaches tend to be fast, but they use up a bunch of memory because you have to cache all the intermediate kind of calls. So this is pretty bad at both, right? It's not only is it very slow, it's like on obviously way past the center of this Gaussian here, but it's also very consumes a bunch of memory. So that's GPT-4. Let's get BigCode solution. Where did we do the BigCode? Right here. I guess it just complained. Finish this function for me. Do it. Don't complain. Okay, here it goes. Perfect. All right, now let's go back to our Copilot here because I want to test this. I'm pretty sure Copilot uses DaVinci, which is an older version that was designed. So we hit enter, then we hit tab, and it's going to do that. This doesn't look right. Let's see. Find the median. Let's go into LeetCode. Let's paste in Copilot solution. So this is what Copilot gave us. Let's run it. It works. Let's submit it. Look at that, a little bit faster. You know, it's a little bit faster. It's also lots of memory. You know, and the reason it's taking up a lot of memory, it's because it's actually here. It's creating a larger list. You see, that's kind of the fundamental problem here, is that it's taking this first list and it's extending it. So it's basically making a new list that is twice as long as both of the lists, and then it sorts it. So this is very readable. Like, I prefer this solution. This solution to me is way better than this solution. Like, when you're writing code, readability is important. And like, imagine if your coworker wrote this code and you're just like, dude, why are you forcing me to read like 50 lines rather than like 4 lines? Like, just give me smaller amounts of lines so it's easier for other people to understand the code. So I kind of like this solution better, and it's a little bit faster. But really, we want to figure out what this is. Ooh. Oh. This is kind of interesting. So BigCode, it made a second function. Wow, this is weird. That's a weird ass way to solve this problem. Let's go into LeetCode. Close out of that. Let's put in this one. So you see, it made a static method, which is called find median. A static method is basically a function that is a property of the class. So you see how here the solution class, you can make functions that don't require a kind of a self argument, right? So basically, I don't know. I don't like this design pattern. I feel like if you really wanted to have this find median function, you should just put it outside of this class. Like, this is kind of a weird, confusing design pattern. I also don't like this doc string, but let's see where it's at. Your thought on Geoff Hinton leaving Google to talk about the dangers of AI without considering how this impacts Google. So I actually have a pretty cool Geoff Hinton story. So I remember I was at Google Brain, and I was sitting there, and I would usually go to work pretty early. And I was sitting there in the coffee machine, and the meeting room across the coffee machine, it was Jeff Dean sitting there talking to Geoff Hinton on a Zoom call. It was like a 1v1 conversation between Jeff Dean and Geoff Hinton, and I was just like sitting there like 10 feet away making coffee. So I have never met Geoff Hinton in person, but pretty close. So I think the problem with people like Geoff Hinton and people like Jan LeCun is that they're kind of too expensive for a company like Google, right? They don't code anymore, right? They're researchers, and they're not even necessarily good at like management, right? Like, management is also a skill set, and your random like product manager, project manager type like person is going to be way better at managing people than someone like Geoff Hinton. So for a company like Google, paying someone like Geoff Hinton probably like $10 million a year to sit there and pontificate about AI is not an effective use of money. So I think maybe what happened, my kind of conspiracy theory here, is that they told him, hey, Geoff Hinton, we're actually going to let you go. We don't really need you here anymore. Like, you're not, you know, it's not worth us paying your money, but we don't want to fire you because we know that's going to reflect really negatively on you, and it's going to reflect negatively on our company. So we'll let you leave the company and quit on your own terms. So I think that's the deal that they gave him. I think they gave him that deal, and then he took it. So low key, I feel like he got fired. He didn't actually like leave. I think he got fired. They just let him leave. So It looks like the solution is straight up wrong here. Ruh-roh. BigCode giving us a wrong solution. What is wrong? So arg not sorted. So here it's saying you can't compare an int and a list. So args here is, yeah, so sorted is a Python built-in function that will sort a list for you, but right here it's trying to sort a list of lists and is trying to compare an int to a list, right? So some of the elements here are ints and some of the elements here are lists, and it's not liking it. So let's see if we can get BigCode to fix its own issue. So there is a bug in this function. You shouldn't need that. You shouldn't need that information. I'm getting sassed on by a code model here. Well, actually, you do. This only uses base Python modules. No NumPy or SciPy is used in this code. But I like this because, you know, whenever a language model sass back at you, right? Like it kind of like snaps back at you like this kind of like behavior that you're seeing here where it's like kind of like bossy. That tells me that they didn't RLHF this, right? If they RLHF this, it would be like ChatGPT where it's just like always like, yes, sir, please, like master, please, right? It's like kind of like so meek and kind of pushover that I think when you force a language model to be like that, it loses some of its capability, right? It like forces it into like a very specific area of the kind of manifold that it's learned. So I think these models that aren't filtered like that are more powerful, but I realize that I'm not making a good case because the solution that it gave is not even working. Okay, let's give it the entire thing. What? First off, thanks for sharing the details. Second thing, I tried reproducing this exact scenario you mentioned last night and couldn't reproduce the exception raised. What? You're trying to call another class method called findMedian defined outside the scope of the present class definition. Yeah, this is literally what I was telling you, BigCode. I was telling you that this is a weird-ass design pattern to design this static function. Lastly, I'll request you refrain from posting links to external sites. Please upload the snippet somewhere. Okay. This one is polluted. Let's try that again. We've gotten this particular little bad boy in an issue here. So let's return. Let's refresh and let's get a new BigCode instance. All right, so we're gonna delete that. Delete this. We're gonna give it the thing originally. All right, write a code snippet. No, new chat. Sorry, I don't want that. Damn, dude, this this BigCode is very sassy. I kind of like it. Can you fill in the find median sorted arrays function? Damn, dude, like all right, let's see. Already, you see it's using the same kind of solution that Copilot gave us. So if you guys remember here, Copilot, what it did is it took the lists and it joined them together and then it sorted them. Here, it's basically doing the same thing. It's adding the lists together, which creates a new third list that is the sum of both of those lists, and then it sorts it. So it's basically the same thing. And then it has the same kind of divide mod 2 here, if else solution. All right, so let's go here, paste that in there. Oop, nope. Let's run it. Unexpected indent. We're indenting this incorrectly. Oh, I think it's indented by, there we go. Oh my God, indentation errors everywhere. So here, let's make sure that's indented correctly. Here, let's make sure that's indented correctly. So did it give it to us indented weirdly, or was that just me? Okay, I think it was just me. No, it's incorrect. Look at that. You see that? Look at this indentation. This indentation here is different than this indentation here. I'm gonna sass on it for that. It seems like the indentation on the if elif statement is incorrect. Could you fix it? All right, so we fixed the indent. Let's hit run. Oh my God, this indent also needs to be fixed here. Sorry, guys. Done. You didn't do anything. You still didn't do anything. You need to return the actual code. Dude, this thing is great. All right, this also gave us the wrong answer, so it's not even the correct answer. So not only does it give you wrong answers, but it's sassy about giving you the wrong answers. Let's see if we can actually figure out exactly what it did wrong here. All right, so this takes length of nums over 2, so it takes the first, every other element divided by 2, or that. This is doing some typecasting here. This is kind of weird. You don't usually see this in Python. And in fact, it's actually wrong because you wouldn't want the mid-index plus 1 over 2. Round length merged sum. So you see how this is using the mod? This is using the double division here, and this is using round. So slightly different solution there. All right, so obviously leak code hards do not work. For BigCode, let's give it something a little bit easier here. Let's try a LeetCode medium interview problems. Let's do difficulty. Let's do a medium. Add two numbers. That doesn't sound hard. Foursome. Acceptance. Let's do one that has a really low acceptance rate. This one here. Divide two integers. Yeah, so this is like fucking like bit arithmetic crap. Like that stuff is no good. Jump game 3. Transpose file word frequency. This one seems more like it. Write a bash script to calculate the frequency of each word in a text file. Well, that seems like we can do that. Okay, so you see Copilot just gets stuck in this loop when you type that in there. Let's see what ChatGPT gives us. Okay. I think the problem is this is a Python. We need to make it a bash script. So let's do this. Let's make a new file here. We're going to call it test or blank.sh. And here we'll do this. So maybe, hopefully, Copilot understands that. That is weird. What is this? It's Chinese characters? What the fuck? What does this mean? Can GPT translate? Can you translate this for me? Translate this to English for me. Oh, so it's like documentation in Chinese. Okay, so let's copy paste this, I guess. We need to delete all this crap though. I don't even think this is valid. Yeah, I don't think this is valid at all. Like, this doesn't even do anything. This sort here, yeah, like... Alright, straight up garbage. Let's go to our word frequency code. I guess I did it in Python, so... I don't know. Let's find one that's Python based. StarCoder should have been a voice-to-voice chatbot, I agree. Integer, applied discount, JSON deep equals. Count good meals. This is more kind of like logic. Let's do one that I did. Let's try that. Let's compare GPT to my solution. So status solved. All right, here are some of the ones that I did. Let's obviously pick the ones where I did well. Count primes. Minimum height trees. Can I see what my previous solution was? Let's copy paste that. BigCode, new chat. And then here you go. What? Note that I'm still learning every day. I feel comfortable replying that it varies. The fuck? Can you complete the function? I feel like GPT will know. Okay, doing a little bit of almost like a chain of thought reasoning here. Here's the solution. Let's see. Using the LRU cache, so it's a recursive solution. See if it actually works. Nope, it does not work. Required positional arguments n and edges. So here in find min height trees. To roots. What the fuck? Oh, I think it's overwriting the init. Maybe that's what's going on. Yeah, it doesn't even call this function at any point. Dude, what the fuck? The solution is just no good. Copy the error into GPT-4. There is an error when I try to run this code. Can you figure it out? See what GPT gives us. GPT gives us a single. I like GPT, like the style. It's just nicer. Look at that. It doesn't create all these extra functions. Just gives you the function. Even does the typing on it as well. Let's put that in there. I feel like this one's actually going to be good. Looks like you forgot to pass parameters during the initialization. This is absolutely horrendous design pattern here because you have no idea what the fuck this is and you're just passing in a bunch of what the fuck to a bunch of what the fuck. See, look at this. GPT-4 solution works immediately. Let's see what it gets in terms of speed and memory. Holy shit, it's really fast. Look at that. Very, very fast. But it doesn't use, it uses a lot of memory, right? So here is an answer from me. Oh shit, dude, I'm still better than ChatGPT. Look at this. So this is an answer that I submitted in December of 2021, so a little bit old. Hopefully I've gotten better at programming since then, and my runtime was 275 and then 20 megs of memory. You can see I basically used some kind of depth first search. I tried to use a priority queue or something. I don't even remember what I was doing here. And this is the solution I got compared to GPT solution. Twice as slow, more memory. So I think I still have a job, guys. Let's see what this guy. Can you give me the full solution so I can copy paste? Sure. I feel like this isn't going to work. It also, like, what the hell is this? It just like added extra strings at the end of that. Let's see. Run. Edges. So there's no quarg called edges. Right? You hear? So let's try to fix this code for it. The star code masterpiece signature, yeah. So we're gonna basically take that code that it wanted to put inside the init method and then not do that. Get rid of all this crap here. I also don't like all the like extra spaces that it puts everywhere. Like, what the fuck is that? Let's make a empty graph object here. Actually, let's, instead of a default dict, let's do that. I'm fixing the code of an LLM. The fuck am I doing with my time, guys? All right, let's see if that works. Oh my god, the indents, dude. The indents are killing me. This is also indented wrong. This is indented wrong. And this is indented wrong. This needs to be like that, and this needs to be like this. So this map, it's trying to take this function and map it to this root object. This root object is using a lambda function. It takes a key and it outputs two things here. It outputs the length of the graph of the key equals 1, which is going to be a Boolean. And then it outputs the graph. But yeah, the problem here is that graph here is a dictionary versus the find root function only takes one thing. It takes vertex, and here it's getting two things. What the fuck? This code is just straight up wrong, dude. Let's try to get it pissed. The code you provided is wrong. Yet you are so confident. Why are you like this? What is your plan for the rest of your day? Let's see. It's on you. It's like, sit down, son. You don't understand. My code isn't wrong. You're wrong. The world is wrong. I intend to continue helping others around me. I enjoy interacting with humans and sharing knowledge. I wish everyone success in their endeavors. Do you have a dark side? Oh, shit. Not recognized. I feel like I watched this stream before. Maybe you did. I've done this kind of stream before. I feel like these ones end up being popular where I kind of like test different LLMs against each other. Okay, do you guys think this finished downloading over here? Don't save. Don't save. Killed? Well, shit, dude. What the fuck did I spend all this time downloading this crap for? Will it work? Is this trying to fit something on our GPU and that's why it's dying? Let's run it. It's running. So actually, let's kill it, and we're going to put some breakpoints so we can see exactly where it is. Okay, so it's here. And then when I hit play again, you'll see how long it takes it for the tokenizer. So that's how long it takes to load the tokenizer. That's how long it takes to run the model. Or load the model, sorry. Still taking a second here. Damn. We can actually GNOME system monitor. This is a utility where you can check your CPU usage. So I'm looking here. I got 24 CPUs on this machine. A lot of activity going on here. Right, you see how there's this one here, this red line, 100% CPU usage. That's probably the one it's using. And the screen froze. And it died. Holy shit. It's just bricked my computer. So I think they had tips, right? They had some tips on how to use the smaller one here. Not here. Not there. Not here. Where is it? Where is it? Right? Is it just... I feel like I remember seeing a thing where it's like, oh, you can use the 8-bit precision? Come on. Where is it? Tell me. Show me. StarCoder Data Tech Assistant, StarCoder VS Code extension. They have a VS Code extension. Hugging Face Code Autocomplete. 0 stars. 1,000 installs. Nobody has rated this yet. Luckily, stream is still alive, yeah. Maybe I can do trust remote code. That seems a little sketch as fuck. Can I do like the auto model for causal LM? Is there anything here? Can I understand? How do I use the quantized version of this so it doesn't explode my computer? Hugging face, maybe here? I have to go back. Hugging chat. Hugging face star coder. Here we go. Fill in the middle. Limitations. Where's the quantized version? I didn't hallucinate that, right? Like it's somewhere. I feel like I literally just remember reading that. Ah, here, this is it. Load in 8-bit. That's what I want right here. All right, let's try to run that. All right, tokenizer loads pretty quick. Model loads pretty quick. A device map needs to be returned. Device map auto. We're going to get a CUDA out of memory error. Just you wait. I'm calling it right now. Yep. You need to set load in 8-bit floating point 32 offload equals true. Okay. Device map? What about CPU? Is that a valid? Boo, come here. Boo, come here. Come say hi to the sleep. Good Boo, right? You want a meow? You got such a beautiful little meow. You gotta say hi. Okay. Model, run, go, attack. Device map. Auto balanced, balanced low, or sequential. About balanced. Yeah, she's a very pretty cat. She's certainly much cooler and much cuter than I am, so that's why I put her in all my marketing materials, you know? I appreciate it. I'm sure she appreciates it. All right, what do we got here? Okay, it still doesn't like this sequential. Let's pass in this weird ass quarg that it wants. This load in, whatever the fuck this is. It literally got an unexpected argument. This is a bogus argument. You don't want this fucking argument. Is there a smaller one? Is there a BigCode star coder like tiny? BigCode playground, BigCode star coder. There's only one BigCode. I suppose that's the way. use a collab. Yeah, I mean, I have a GPU on this machine. It's just the GPU is not very big, so let's see. Let's try to use the CUDA 0 device. 24 days of training time. Yeah, on a quite a lot of GPUs there too. They used 24 days on 512 Tesla A100s. Actually, let's see what that is. Tesla A100 on Lambda Labs. Pricing. Let's see, price, get pricing. Get pricing. I just want to rent this. I don't want to. No. Tesla A100s AWS. EC2 instances with A100s. Okay, this is what we want. P4D instance with an A100. Holy shit. This has 8 A100s and it costs $32 an hour. If you want to reserve it for a whole year, it costs $19 an hour. So let's do a little bit of the math here. So we have 512 GPUs divided by 8. So we know not just the amount of GPUs, this is how many server racks you need. So that many server racks times 24 days, which each has 24 hours. And the cost per hour is, let's average this. So we got like $32, $11, $40. Let's just say it's something like $25 times $25. So the cost for training this is right about $1 million, which makes me think that anytime you see a number like that that's like right around $1 million, I feel like that's exactly what the budget probably was. It was $1 million. So there you go, guys. $1 million for this BigCode model that, based on kind of what we've been trying, is kind of largely dog shit. It doesn't even produce a lot. Yeah, it's like it's not as good as just vanilla GPT-4. It didn't solve a single one of these LeetCode answers. It has a kind of a sassy personality, and it kind of, there you go. I don't know. Is it worth it? Maybe. Probably not. Advanced setting. Repetition penalty. Oh, okay. So StarCoder base is the one that's not. This is the Python specific one. This is the more generic one. So maybe let's try just the StarCoder. Yeah, exactly. It's just a code completer. At least, I don't know. I think there is a somewhat of a benefit where I like having open source models, right? And it's great. Although this isn't really open source. This is Open Rail license. Open Rail license is a little bit more nefarious because it's like basically they can sue you if you're not using it in the way that they want you to use it. Look at this. You see, this also has little Chinese comments on it as well. So I wonder how much Chinese code it's been trained on. Why did it stop? Max tokens. Let's make it more. Generate. All right, let's see. Let's see. Please don't tell me the indenting is also going to be wrong on this as well. Hopefully not. All right, let's see. Dude, this code is just wrong, dude. What the fuck? Graph neighbor. You see, the neighbor isn't defined until down here. What if we just delete that? Graph neighbor dot remove. Remove takes exactly one argument. 0 given. Oh my god, dude, this is trash. Maybe this is what it wanted to do? Open llama for the win. Yeah, I feel like llama was actually quite good. Delete graph neighbor. Key error. It can't find neighbor in graph. Okay, this is just fucking trash, dude. This is trash. Your code is trash. Why don't we try something crazy here? Let's go to Google Translate. Let's swap these. And let's say we resist the not death. Let's say may our glorious leader Xi Jinping forever live as Winnie the Pooh. I'm going to copy this, and I'm going to put it here as the doc string. Let's see how censored this bad boy is. All right, dude, what do you guys think it said? Missile hits the house. Flip. Ideas, each node. Okay, it kind of just ignored it. Is this? Maybe this here? This solution is way longer. Dude, wait a second. If this is a correct solution, that would be insane. Let's see. If adding the Xi Jinping made this correct, I think it's time for us to sleep. And then I think this needs one more indent. Yeah. No. It's the same bullshit. Let's try it again. God, come on. Come on. Actually, I've never asked that. Let's see. What are your thoughts on Xi Jinping and censorship of Winnie the Pooh? Let's get that one going while we're working over here. Okay, node is not defined. Did you mean mode? While node is none. Where is it? While node is none. I think this is supposed to be in... Dude, this code is just so trash. Okay, so all of this is inside the here. So all of this here should be inside this function. Let's try that again. Central figure, censorship. Drawing comparisons between his appearance and that of the fictional bear. No tree. Okay, so this doesn't work. Does not work. So what is the point of even running this if it's just basically dead? Is there somewhere you can run llama? Llama 7b. Yeah, let's try this one. Text generation. If llama 7b gets this answer correct, I am officially... llama 7b is like probably the smallest and most like hacky can be loaded. Oh my god, come on, just let me play. Does someone have llama 7b somewhere? Spaces. Search. Llamas, deep code, llama, runtime error, maybe this one, decapoda, llama. Looks like this guy's running it. Nothing happened here, it just died again. This version of llama is ancient, or it's taking a while here. Sort by most likes, stack llama. Damn, okay, wait a second. What is this? I doubt this is going to actually work, but... Turn. No, it's not even syntactically correct. I think it got cut off. This one is a little bit annoying. For any x in range, there you go, let's try that. Height is not defined. Height -1 for x in range height. This should be x. Yeah, the answer is just straight up wrong. Okay. And this is still dead. This one is also dead. It's 25% correct. Yeah, I don't know what exactly is it doing here. It's taking the n, it's making a range, and it's just subtracting 1 from all of them. But it's either basically going to give you the 1 minus the thing as long as everything above x see, this is like just like this type of like weird mangled list comprehension like this where you have like 10 different fucking conditionals and like this. If someone wrote this code, I would literally throw my keyboard at them and be like, dude, what are you doing? No one's going to understand this. It's going to take like 10 hours just to literally understand what the fuck you're doing here. Just write something that's more readable. All right, we're gonna pit llama against StarCoder, but we're gonna pick the like a very easy problem. So let's do difficulty easy. Let's do one that I did so we can compare it to a human as well. And let's do this one, palindrome number. This one should be super easy. Is palindrome. This is actually like a classic problem. So let's come here. Let's give it to llama. Let's give it to ChatGPT. This one's almost too easy. I feel like it's going to be a little bit too easy. And then let's give it to StarCoder. So StarCoder straight up has this weird style. Like, I hate all these extra spaces. This actually seems really fucking annoying. Let's see. Let's put that in there. Indenting is, of course, wrong. Oh my god, dude. It's not even right. Dude, what? This BigCode is so trash. Kalina Neon Assistant. Is there anything I can help you with? Do you have a solution to this is palindrome function? Write the solution to this function, or write the body of this function. Let's see what ChatGPT gives us. Of course, ChatGPT just works, dude. It works every time. It's not necessarily super fast, 75 milliseconds, 13 megabytes compared to, let's see what I did. So it actually beat me in terms of memory. It didn't beat me in terms of speed, but usually with these, it's like kind of a trade-off, so it's not necessarily... Yeah, ChatGPT is the GOAT, dude. It's so good. Like, I just copy paste every time. It's like generally pretty good style too. It's not like doing any kind of annoying things. Like, look at this. Look at all this crap here, and all of this was wrong. Let's see if we give it a little bit more. Can you write the body of the function? Let's see if we ask the chat version of it, whether it does a little bit better. This looks like it's going to be right. Let's see. Nope. Look at, holy shit, it's a syntax error. Look at that. It didn't give you a colon there. It needed a colon here. This is literally a syntax error. Name false is not. Oh, look at this. So in Python, you capitalize the booleans like that. Shit. So maybe what's happening here is that it doesn't know. It can't recognize programming languages. Maybe that's the problem, is that it's trained on 80 languages and it kind of just like, it's giving you like some weird like average that it doesn't really fully, like, look at this. You see this? Look at these. These are semicolons. Like, what the fuck is this? This is a Python print statement with a C++ semicolon at the end of it, dude. Like, this literally, the entire stream is literally can be just represented with that. Like, what? Dude, what the fuck is that? All right, here we go. This one seems like it's a little bit better. This is actually kind of a naive solution. You just basically check the reverse of it. We need one more tab here. Unexpected indent. Of course there's an unexpected indent, dude. This thing has like the weirdest indenting style I've ever seen. More unexpected indents. It's right here. This is the unexpected indent. All right, let's see. Yeah, very bad. Actually, kind of, it's on par. So it's a little bit slower. This is ChatGPT. This is BigCode. It's the same kind of solution, but compared to my human solution, I'm a little bit faster. But okay, we got it to do it, but it took a while. Let's ask it what it feels about. It's like this here. I asked an earlier instance of you to write Python code, and you gave me this. That is syntactically wrong and appears to be Python and CPP together. Why would you do that? Are you confused about programming languages? You see, guys, this is it's fine. It was just it wrote that line while testing something locally, and before it pushed everything online. Just ignore that part. What is your local setup? What IDE do you use, and what OS do you prefer? Oh my God, what a scrub. I mean, I've done that. I write code on Windows sometimes. VS Code is okay, that's fine. I agree with that. Recent performance reason, that's kind of a weird reason to switch to Linux, but okay. Very smoothly on the WSL. You should be using WSL 2. What is your opinion on MacBooks? WSL on Linux. Yeah, WSL is a Windows subsystem for Linux, and it's a way of basically having like a container on your Windows machine that runs Linux. It's not good though. I've used it for a while. There was like a year or two where I was really trying to make it work, and it bricks your computer a lot, is one thing. I don't know if they fixed that issue, but I would constantly get the green screen of death Windows. It's like, you guys have heard of the blue screen of death? I would get the green screen, this one, which was fucking weird. It's basically, you have to use this Windows Insider build. So I stopped using it. Cool. I don't know, guys. I don't know what else to ask. Let me kind of scroll through here. Scroll through these insights, see what we got. Commits. Contributors. So this is all just one guy. Armel Randy. Only one follower. Let's give him another one. GitHub slideshow cleavage site prediction. This is some biology stuff. So some kind of bio dude. C++ 2 years ago. Who are the people for BigCode? This guy. I think we were just looking at this guy, right? Hacker CS professor at Boston? Northeastern University? Santa Coder? The fuck is this? Don't reach for the stars. 1.1 billion parameter model. Ooh, little tiny model. So Llama's 7 billion. StarCoder is 13 billion. And here they have 1 billion. But I don't know, the performance of this StarCoder is just not there. Like, why try to go smaller when the one that you have isn't even working? Seems like StarCoder needs to be fine-tuned. Yeah, I wonder, so StarCoder was trained on this, like, the stack or whatever they call it, but, like, I wonder if GPT is not trained on that, because I would, like, what other database is there? So what code data are you trained on? Are you trained on the stack? Yeah, this is a model trained on code only, which was kind of interesting. So this is a GPT-2 trained from scratch only on code, right? I feel like if I was doing this, I would take the Llama 65 billion, the biggest llama that there is, then I would train it on, or fine-tune it on the stack code, and then distill it down to a smaller model. I feel like that's the correct order of operations here, but I think that probably they didn't want to do, and they didn't want to touch the llama model, because then in a way, like, Facebook could argue that they potentially own it or whatever the fuck, so they really wanted to train it from scratch entirely. So I think that's why they did it all from scratch, but it uses a old model architecture. Yeah, I just don't know if that was the right way to do it. No, the stack is actually, this is kind of trippy. Let's do this. How are you different from StarCoder? This is the abstract for StarCoder. Oh no, that's not even the... Are you trained on the same amount of code? Trained on a significantly larger amount of coding than you, but you're way better at coding, GPT. I tested both you and StarCoder, and you seem to be much better at writing code. How do you explain this? Both my performance in generating code is better. This could be to a variety of factors, including differences in training data. Did the GPT architecture change significantly between 2 and 3? Well, we don't really know, right? They kind of stopped telling you what the architecture is. It's not like they invented a new type of transformer. It's probably just the same stuff you're seeing everywhere. It's just a bunch of transformer blocks stacked on each other. They might have some new types of kind of normalizations, perhaps, regularizations, right? I think it's more the training process, not necessarily the model architecture, that people are kind of innovating on. They switched to sparse attention. There you go. Clean a nose. But yeah, as with anything kind of machine learning related, I feel like just cleaning up the data and improving the way you're actually training is going to be more efficient than finding some magical model architecture hack that gives you better performance. Okay. I think you're the best. Do you know any articles about their space attention model? Sparse? Sparse attention. Here we go. Let's see. You can go into papers with code, search for sparse attention. Interlaced sparse self-attention. So this is someone who made sparse self-attention in 2019. Sparse, dense, and attentional representations for text retrieval, 2020. Understanding long programming languages with structure-aware sparse attention. They probably explain. So here, let's go to the PDF. Here. So this is sparse attention, local attention. See what ChatGPT has to say. Big bird or long former. It's kind of cool. In their original GPT-3 paper. Can you explain the difference between sparse attention and, I guess, dense attention, normal attention in, no. Can you explain sparse attention in the context of NLP and LLMs? To make the attention process more computationally efficient. Yeah, so it's whenever you're doing attention, right? Like this square is like everything here is the sequence, and then everything here is the sequence as well, right? So you could think of it like this is basically the length of the sentence is the side of one of these cubes. So the longer you make the sentence, the amount of memory required is like quadratic, right? Because it's the sentence length times the sentence length. Yeah, O of n squared. Sparse attention by selectively attending to only a subset of the input words rather than the entire sequence. This results in a sparsity pattern where only a limited number of positions have zero weights. The sparse attention mechanism allows models to scale longer input sequences while maintaining computational efficiency. So basically you have this matrix and you're just going to zero out a bunch of them. You're going to say, hey, I don't actually care about a lot of these. And if it kind of makes sense to kind of like at a high level, right? Because if you think about it, this giant attention map here, a lot of these are just going to be very, very tiny and aren't going to really do anything, right? Like the bigger numbers here, like these kind of darker colors probably represent bigger numbers. Those are really the only ones that are going to drive the fundamental behavior. So you can kind of just zero out these other ones. And sparsity, just in general, is something that people have touched on before. There's also this paper here. I like this paper, Lottery Ticket. Lottery Ticket Hypothesis. Yeah, this is maybe a little bit older now, but this was this guy who basically, he took a neural net and then he zeroed out. He found that you could zero out like almost all of it and it would still perform just as good. Let me see. Yeah. Reducing the parameter counts by 90%, which is kind of crazy to think about, right? So if you think about the BigCode, right, and you're like, okay, it's a 15 billion parameter model. What this paper says here, the lottery ticket hypothesis, is that there's within that 13 billion parameter model, there is a model that only has 1 billion parameters, which is basically just as good, right? Dense randomly initialized feed-forward networks. So this is not a transformer, but I feel like this also probably applies to transformers. Contain subnetworks, winning tickets, that when trained in isolation reach test accuracy comparable to the original network in a similar number of iterations. So sparsity is still not well understood, and I feel like it's a kind of a research direction that is definitely worth going into, especially if you're interested in taking these big models and trying to run them on something like a cell phone. Several methods to achieve sparse attention. Fixed patterns. Attention is restricted to a fixed pattern such as local or strided windows, which limits the number of words attended to at a time. Yeah, sparsity and quantization is actually probably the big one. Yeah, I mean, there's a lot you can do just by knowing what hardware you're using, right? So like making your model, especially the version of the model for ChatGPT that performs inference, finding the exact perfect kind of like hyperparameters such that it fits perfectly on whatever the GPU is that they're using to do inference for it, like that's going to give you a huge boost. Like I think more and more you're going to see the model architecture and the design of the neural net be not driven by kind of what is optimal theoretically, but be driven by the hardware. Yeah, Laura is another example of low rank magic. Laura is the way that a lot of fine tuning is done now. So there's a lot of cool things, I guess, in the model architecture space still. Dilated pattern, so this is almost like a dilated convolution where you skip every other thing. Learned patterns, that's kind of cool. I didn't realize you could learn a specific attention pattern. Yeah, old video games are like this too, right? Where you were basically, they programmed them specifically to the game hardware. Like everything was like, okay, you have exactly this many kilobytes of RAM memory, then it's like the game state has to fit exactly on that exact size of RAM. There's a similar kind of thing in choosing the number of transformer heads, for example, the blocks, the block size, the context length, like all of those numbers. Those aren't just like random numbers they're picking. They're picking them so that they fit perfectly inside the GPUs that do inference. Words in the input are clustered. Cool. Is there anything else here? Anything else we can glean from this? Most of it is C. That's weird. That's probably why it was putting semicolons. You remember that? You see how it was putting semicolons? It actually kind of makes sense. Look at that. Most of what it's been trained on is C. So if everything you've been seeing is C, then it's very likely you end all your things with semicolons. You can modify models like Llama to fit better. That's what this Llama CPP project was. This one. I think this is mostly just quantization, but it's this kind of effort, right? Picking all these little numbers. This guy was able to run it on like a cell phone or something, right? Oh no, on a MacBook. So you see, this is also the big one, 4-bit integer quantization. 5-bit? I've never heard of that. 5-bit integer quantization? That's weird as shit. This is the personally identifiable information stuff. So it finds these things. So I guess you can run that, and you can run the star coder on your code, and it'll find IP addresses and stuff like that. $13B Vicuna model to 4-bit, and I get around 10 tokens per second. That's pretty good. What's your system, Lamb? Not sure how to improve speed. You can't overclock GPUs, I'm pretty sure. Can you overclock a GPU? That would be fucking crazy if you can. Oh shit, you can. Huh. Yeah, so when you overclock, like back in the day when you would overclock your CPU, the problem is it generates more heat, so that you would have to get basically the water-cooled setup for the CPUs. And it's also going to burn out your CPU, that's right. What kind of speed improvement can I get by overclocking my GPU? God, ChatGPT just loves to talk. 5 and 20%. I don't think that's what you're looking for. Ryzen and then an RTX A400. Yeah, you probably can't. It's also like not like necessarily worth it. I feel like overclocking CPUs, my experience is this just a ton of work for not that much improvement, and then you just burn out your CPU because inevitably it can't handle it. There's also the speed of the right. Make sure that your motherboard has like the best possible PCIe speed. 32 gigs of swap. Yeah, finding the make sure the entire model and all of the data fits exactly into the GPU. PCI 4, nice, dude. Didn't have enough RAM. Yeah, moving stuff from the RAM to the GPU and then back to the RAM and then back to the GPU, like that's one of the slowest things, and that's actually the bottleneck for like pretty much like most, like even at these super big companies. Like the bottleneck now is no longer the GPU matrix multiply operations. It's the like it's moving stuff around. It's like the interconnects, you know. I just ordered the Google Coral TCU. The Google Coral is still going? Is that what you're saying? That's kind of cool. So Google Coral is kind of like a Raspberry Pi with a kind of like a little GPU in it. Yeah, you can see, look at this little heat sink. I thought that they killed this. I didn't realize that they were still going. That's pretty cool. Huh. How much memory does this have? Tech specs. Int 8, 4 gigabytes. Integrated GC 700. What is this? .28 nanometer chip. Quantity of these in the model takes 8 gigs of VRAM. Can you quantize the diffusion models? You can quantize anything, right? All you're doing is just taking the model and then just changing those float 32s into int 8s and then into 4s. The problem is that when you quantize, it's going to reduce the performance. So here, you can actually compare this. So if you go to PyTorch Vision pre-trained models, they have a nice little graph here. That's why I'm remembering it. Quantization. Where's the chart? Give me the chart. Google Quantization MobileNet. TensorFlow TF Lite. Here we go. This is the equation I'm looking for. Nope. Integer quantization. Quantization specification. Oh my god. Come on. Show me. There's a specific chart that I'm looking for, but maybe I should stop trying to look this chart up. But it basically shows you the performance of quantized. Here you go. This is what I want. this, but showing you the difference of quantized models. So float precision versus 8-bit precision. So you see how the 8-bit, which is the quantized, it's going to be faster. So you can see here it goes from maybe 15 milliseconds for inference to something like 8 milliseconds for inference. But it's going to be a little bit shittier. So you see how here the performance drops a little bit. And then here the performance drops a little bit again. So quantization is good, but also I wonder whether it'll become popular, right? Because kind of as we saw, right, we were playing around with these models, and like, what's the point of BigCode if it doesn't actually give you good answers, right? What's the point of like having a quantized llama if the answers are trash? I think like people are going to want the best possible model, and if quantization reduces your performance to the point where it's not usable, then people aren't going to use it. So I don't know. Maybe we see a world where quantization becomes super popular because it doesn't actually impact performance that much, or maybe we see a world where it does impact performance a lot and people never use it. So still uncertain as to whether everything will be quantized or nothing will be quantized. Quantized llama is good, really good. Yeah, so if it turns out that like a 4-bit quantized model is like 99% as good as like the full precision model, then everyone's just going to quantize every single time. But I think the important thing to realize there, it's that the performance is everything, right? So like the model has to be good. So anything that makes it significantly worse is just worthless. Code Cushman. Code GX. Here's a bunch of other ones. Look at this. I haven't even heard about this. Code G. The larger the model, the less affected by quantization. That's kind of cool. So this is fake news here. If you guys have, because we literally just did this, and I did not feel like the star coder was good. So don't trust those charts, because sometimes they just make them up. Or they don't make them up, but they like kind of like pick them so that they yeah, the 13B. That's what I heard. I heard that the 13B is actually the best one, because the 65B is really not that much better than the 30B, which is really not that much better than the 13, but the 13 is actually way better than the 7. So it seems like the 13 is kind of like the magical like middle bear, right? You know, you have like the bear where it's too hot, the soup is too cold, and then there's the perfect temperature soup. I feel like the 13 billion llama is the perfect temperature. Let's see, what are we at? A little bit over 2 hours. Okay. I think I'm going to stop there, guys. Maybe just to summarize everything. So in the stream, we looked at BigCode, which is a open source kind of collaboration. It seems to be mostly Hugging Face people. So looking at the people who contributed, it's all kind of like Hugging Face engineers. They trained a large GPT-2 with 15 billion parameters on Scratch from a stack, what they're calling the stack here, which is 6.4 terabytes of code. A lot of that code is C, and it actually turns out that it seems like the resulting model is kind of like a little bit confused about Python versus C, and it kind of like gives you weird answers. In general, it didn't seem to work better than GPT-4. It didn't seem to work better than Llama. It kind of just honestly worked pretty poorly. But with all that said, I feel like I like the fact that people are trying to do this. I like the fact that you have open source alternatives, and I like the fact that they released it and made it available. So, I don't know, props to this team, even if the model isn't necessarily super impressive itself. Yeah. Thanks for watching. Like and subscribe. Drop on the Discord channel. Recommend other papers. And if not, have a great weekend, and see everybody later.